The next skill for this section looks at solving formulas for a particular variable. So to review this, we're going to look at a very familiar looking linear equation. Solving 2x plus 9 equals 17 for x is what we were doing back in Unit 1. And the steps there haven't changed. So I would start by subtracting 9 from both sides. And then dividing both sides by 2. In this section, we're going to be looking at formulas that don't have numeric values, like the 2, 9, and the 17. So if we look at this formula over here, it's much the same form as this one, except instead of the number 2, we have the letter K, and instead of the number 9, we have the letter C, and instead of the number 17, we have the letter M. But the process that we go through to solve for x is still going to be the same steps. My goal is still to get the x on its own, so I need to remove the c and the k. Since the c is being added to kx, I'm going to subtract c from both sides, leaving me with kx on the left and m minus c on the right. Do be careful of order with this because subtraction's not commutative. It does need to say m minus c, not c minus m. Then over on this problem, to get x alone, I divided by 2. Well, here I have a k multiplying by x, so I'm going to divide by k on both sides. That gets x alone on the left, and on the right I now have m minus c over k. And because I don't know the values of m, c, or k, this is my final answer. What I've done is simply rearrange this equation to isolate the x instead of the m. Let's try it with another problem. Looking at this problem, we're asked to solve for t. I'm going to eliminate that 1/2 first by clearing the fraction. So by multiplying this whole problem by 2, I will get 2y equaling, the half is now gone, tn squared. You'll notice that this is all a single term. It's a pretty complicated term. It's got 2 variables, an exponent, and a fraction in it. But because there are no addition or subtraction symbols anywhere in the middle there, that is a single term, and multiplying the 2 by the 1/2 will eliminate it. The next step that I need to do is figure out how to get rid of that n squared. Well, since the n squared is being multiplied by t, dividing by n squared will get it to go away. But I need to do the same thing on the other side. So my final answer will be 2y over n squared is equal to t. One final example. C is equal to 1/4 n times the quantity a1 plus a2. Again, I'm going to choose to clear the fractions first so that I don't have to distribute them. So when I multiply this whole equation, each term in this equation by 4, I'll get 4c equals n times a1 plus a2. And you'll remember from section 2.3 where we cleared fractions that because these are in parentheses, the 4 will get distributed over the a1 and 2 when the distribution happens, or the 4 times 1/4. Now I am going to need to distribute because it's the a1 that I'm trying to get alone. So my next step will say 4c equals n a1 plus n a2, with the n being distributed onto a1 and also onto a2. Now I can subtract an na2 from both sides. Again, subtraction's not commutative, so I need to be careful to make sure that I'm keeping this in the correct order. The Na2 is getting subtracted from the 4c, not the other way around. And that leaves me with Na1. And then the final thing to peel away is that letter n. So by dividing both sides of my equation by n, I get the final result, which is that A1 equals 4c minus Na2 all over n.